In this video, we are going to explore the different number of solutions we can get to linear equations. So far, we've only been getting one solution for every equation we do. That means that there's only one answer that we can plug in for x to make the left side of the equation equal to the right side of the equation, or to make the equation true. So to solve this equation, 3x plus 7 equals 9x minus 1, we notice that the left side of the equation and the right side of the equation can't be simplified any further. So now we're going to start trying to move things around to isolate x. So since we have variable terms on both sides of the equation, I'm going to subtract 3x. Don't forget that it's minus 3x, not just minus 3, but minus 3x. Now I have 8 equals 6x, so I'll have to divide by the coefficient, so divide by 6. I get x is equal to 8/6, or 8 divided by 6. Because both the numerator and the denominator are divisible by 2, I'm going to reduce the fraction to end up getting that x is equal to 4/3. So to check my answer, I'm going to plug in 4/3 where I saw the x. This 3x again represents 3 times the quantity for x, so times 4/3. So I'm going to rewrite 3 just as a fraction form, so it's easier for me to multiply these fractions together. So 3 is the same as just 3 divided by 1, and then 9 is the same as just 9 divided by 1. Then from here, I'm going to multiply the numerators, so multiply the numbers on the top, and then multiply the denominators. So I get 3 times 4 is 12, 1 times 3 is 3, so I have 12 over 3, plus 7, 9 times 4 is 36, 1 times 3 is 3, minus 1. Then from there, 12 divided by 3 simplifies to 4, and then 36 divided by 3 simplifies to 12. Simplifying the left side, I get 11. Simplifying the right side, I get 11. So I know that my answer, x equals 4/3, is correct. So this answer that we got for x is equal to 4/3. 4/3 is the only value that will make the equation true when I plug it in for x. It will make the left side of the equation equal to the right side. So that tells us that this particular equation has only one solution. There's only one answer that will make this equation true, or that will satisfy this equation, and that is when x is equal to 4/3. So let's look at another possibility. We'll notice when we try to simplify this, something interesting will happen. So starting with the left side of the equation, there isn't anything for me to simplify. Looking at the right side of the equation, I do need to distribute this 2 to both of these inside terms. Now you might already notice that something's a little strange about this equation, but I'm going to still approach it the same way that I would for any other equation. So looking at this, my left side and my right side are both fully simplified. So now I need to move the variable terms all over to one side. So I'm going to subtract 4x from both sides. Usually I would subtract the smaller of the variable terms, but in this case, since they're the same, I would just subtract that. So 4x minus 4x simplifies to 0. I bring down the 6. 4x minus 4x simplifies to 0 again, and then I bring down the 6, and now I end up with this interesting situation where we have 6 equals 6. It is always true that 6 is equal to 6 because they're the same number. And so what that tells us is that it doesn't actually matter what number we plug in for x, because if we take some number, multiply by 4 and add 6, and compare that to the same number, multiply by 4 and add it to 6, we're going to get the same answer. It's just going to be the same number is equal to the same number. So let's say I plug in x equals 1. This would mean that everywhere I saw an x, I'm going to replace with a 1. And when we do that and simplify, we end up getting that 10 is equal to 10, which is correct. If I were to plug in a different number, let's say I tried x equals -3, then when I plug that in for x, I would end up getting the left side equals the right side, that I get -6 is equal to -6. So we can see here, it doesn't matter what kinds of numbers we put in or what number we put in. If I plugged in a natural number like x equals 1 or a negative integer like x equals -3, if I plugged in a terminating decimal, which is a rational number, or even something like pi, which is an irrational number, it is still going to work that the left side is going to equal the right side, because we have the same equivalent expressions on both sides of the equation, and we always end up getting this statement where it's a number equals the same number. So we would describe this equation as having infinitely many solutions. Alternatively, if we didn't want to actually write out the words infinitely many solutions, we can use this symbol, which looks like a fancy R, to represent something having infinitely many solutions. So it's the same thing whether you use the symbol or whether you write it out in words. I'm not going to have you memorize or use the symbol if you don't want to, but it's kind of like a shorthand way of writing out this statement. Now we're going to examine the last possibility for the number of solutions to linear equations. So when I try to simplify this equation, on the left side, there's nothing for me to combine, so I move to the right side. I do need to distribute that too. Then from there, you might notice again that the equation looks a little weird. I'm going to still approach it as I would normally by subtracting 6x from both sides. Then I end up getting negative 5 is equal to 8. So negative 5 is never equal to 8. So what that tells us is that there is no number we can plug in for x that will make the equation true. So because there's no possible way for us to make the left side equal the right side, we would say that this equation has no solution. Instead of writing out the words no solution, you can also use this symbol, which is a circle with a slash through it, to represent an equation that has no solution. You don't need to use the symbol, but I just wanted to introduce it to you and call attention to the fact that this symbol does not represent the number 0. I know that in other contexts, when you have a combination of the letter O with the number 0, people sometimes put a slash through the 0 to distinguish between them. But in math, this symbol has a different meaning, and that meaning is that there is no solution. So in summary, looking back at your notes, there are these 3 different possibilities for the types of solutions we can get to linear equations. One possibility is one solution, which is the one that we're most used to, where we end up just getting x, or whatever a variable is equal to just some number. That means whatever that number is the only answer that will make the left side of the equation equal to the right side of the equation. Another possibility is you can get infinitely many solutions. And when you simplify your equation, that's going to end up looking like some number is equal to that same number. So the left side is equal to the right side. The last possibility is if we have no solution. And when you simplify, you're going to end up getting some number is equal to a different number, that it's not true. That, like earlier, we had negative 5 is equal to 8, right? That those are not the same numbers. So we're going to use that information to figure out then how many solutions each of the following equations has. So you can pause the video, and then when you're ready, check your answers. Using my approach to solve my equation, I'm going to end up getting x is equal to 3. That means I just have one solution. So x has to be 3 for the left side to equal the right side. If x is any other number, then they won't be equal. It won't make the equation true. For this next problem, when I simplify, I end up getting negative 8 is equal to negative 8. And since that is always true because those are the same numbers, that means I will have infinitely many solutions. I can plug in any number for x, and the left side of the equation will equal the right side of the equation. After simplifying, I end up getting that x is equal to 0. X is equal to 0 is still a solution. That tells me that x has to be 0 for the left side of the equation to equal the right side of the equation. Therefore, I end up just having one solution. For this problem, I need to distribute and combine like terms, and then I can start moving the variables over to one side of the equation. I end up getting negative 14 equals negative 7. Since that's never true, because those are two different numbers, my answer is going to be that there is no solution. There is no number I can plug in for x to make the left side of the equation equal the right side.